Hey friends, my name is Z and you're watching MakesItEasy. Welcome to a new video for IGCSE at Math, and today we have rules and examples for trigonometric functions or trig functions. And we'll start off with some basics, but before you get into it, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And we'll move on to some basics for SOH CAH TOA. And I'm sure we've seen this during Key Stage 3 or Year 7 to Year 9. But here's just a recap. We have a right angle triangle right here. And the longest side is always a hypotenuse right here. And let's say if this were to be the angle theta, this will be adjacent because adjacent is like right next to each other. This line right here will be adjacent. And this length right here will be opposite because it's opposite to the angle right here. So means SOH sine theta equals opposite over hypotenuse. Cos theta is adjacent over hypotenuse, and tan theta is equal to opposite over adjacent in terms of the length. Right here, length. Then we have some special angles for trig functions and trig ratios. So we have sine theta, cos theta, and tan theta. And here we have three new ones, and they are called the reciprocal identities. So let's just zoom in. CSE theta, or like cosecant theta, is equal to 1 over sine theta. And sec theta is equal to secant theta, like secant theta, which is equal to 1 over cos theta. And cot theta is equal to cotangent theta, which is equal to 1 over tan theta. So the way that I know which is that just look at the third letter for each reciprocal identity. So this would be S, C, T, and they correspond to the trig functions that's reciprocal right here, like S sine, C cos, and T tan. So here we have some trig ratios like sine theta. When theta is 0 degree, it will be 0, and when 30 degree, it will be 1 over 2, and so on. And this will be quite useful when you want to solve equations quickly, and then you can just skip your calculator and just write it out straight away, like sine 90 degree is 1, and so on. And the reason why some angles are not defined, like let's say tan 90 degree, is because if you draw the tan graph like so, there will be an asymptote right here at 90 degree, where the graph won't meet. It will just go infinitely close to that line, but it won't meet, so there's no solution. So now we have some cast diagram, and the cast diagram helps us to see which quadrants the trig ratios are positive. So here we have quadrant 1, 2, 3, 4 going anti-clockwise. So I remember it as ASTC, or add sugar to coffee. So in quadrant 1A, all trig ratios are positive. In quadrant 2, S, only sine is positive, 3 is only tan is positive, and 4 only cos is positive. So cast diagram will be quite useful to determine those basic angle, like alpha basic angle. So let's say when you have this right here, this will be the alpha angle, the basic angle. And the basic angle alpha only extends from the x-axis. So it will be like this could be alpha, this could be basic angle, and this. But it won't, this is not a basic angle. So let's say if you have this angle right here, if you have 110 degree, and you have to find the most basic angle, the basic angle has to be the smallest that you can find. And if you do this, this won't be a basic angle because it's just the angle that's given. You have to find this angle right here for the basic angle. So it's basically 180 degree minus 110 degree to get 70 degree as a basic angle. Then we have some basic identities. So we have some co-function identities. So here's just a quick note of the degree to radian conversion. So number 1, we have cos and sine. So how they relate is that cos 90 degree minus theta will be equal to sine theta, and sine 90 degree minus theta will be equal to cos theta. So here's a condition where sine A equals cos B if A plus B is equal to 90. So let's say if you have cos 40, it will be equal to sine 90 minus 40 degree, which is equal to sine 50. And you can see how they relate because 40 degree plus 50 degree is equal to 90 degree. In number 2, we have tan and cot, which is the reciprocal identity. So tan 90 degree minus theta will be equal to cot theta, and cot 90 degree minus theta will be equal to tan theta. And these two are basically flipped, so we'll just ignore this first. So just like the first one, tan A equals cot B if A plus B is equal to 90. And for the last one, sec and cosec, it's basically the same as the two previous ones, where like 90 degree minus theta will be equal to this, and 90 degree minus theta will be equal to this. Because we know that sec right here, secant, is 1 over cos theta, and cosec right here is 1 over sine theta, cosecant, and this basically relates to the first one. So the third one and the first one are basically the same. Then we have some extra identities, the difference between even and odd function. So only cos theta, like cos function, is even, meaning that cos minus theta, where the minus is in the bracket, you can basically just ignore the minus because cos minus theta will be equal to cos theta right here, because it's an even function. And then I'll just skip through this first. And then we have a sine, which is an odd function. So sine, it means that sine and tan, which are both odd function, sine minus theta will be equal to minus sine theta, where you pull the negative symbol out, like this. And because they are not even function, you have to take into consideration of the negative. Then we have some angles right here. Cos theta will be equal to cos 360 minus theta, and sine theta will be equal to sine 180 minus theta, and tan theta will be equal to tan theta plus or minus 180, which will come in handy when we're going to solve some equations and some expressions. Then we have some Pythagorean identity. So we can just split this into 3. And they look just like Pythagoras theorem, where like a squared plus b squared equals c squared. So number 1, we have sine squared theta plus cos squared theta equals 1. And you can rearrange it to get sine squared theta the subject or cos squared theta the subject. Number 2, tan squared theta plus 1 equals sec squared theta, and you can rearrange to get tan squared theta the subject. And number 3, cot squared theta plus 1 equals cosec squared theta, and you can just rearrange to get the subject. And reminder that sec squared theta just means 1 over cos squared theta, and cosecant theta is equal to 1 over sine theta, sine squared theta, like so. Then we have some quotient identity, and tan theta will be equal to sine over cos theta, cot theta or cotangent theta will be equal to cos over sine, because we know that cot will be equal to 1 over tan theta, and tan theta right here is just equal to this, so it's basically equal to 1 over sine theta over cos theta, and you can flip it around. Then we have sec theta, which will be equal to tan theta over sine theta. And this one right here, cosec theta will be equal to sec theta over tan theta if you were to rearrange it. Then we have some double angle identities. And these won't come up much in maths, and in fact they'll just come up during A-level maths, but here's just a quick look ahead at double angle identities. So sine 2 theta will be equal to 2 sine theta cos theta, like 2 sine theta cos theta. Then cos 2 theta will be equal to this right here, cos squared theta minus sine squared theta. You can rearrange everything to become this or this using the Pythagorean identity that we saw just now. Then tan 2 theta will be equal to 2 tan theta over 1 minus tan squared theta. And some extras. So cos squared theta is just equal to cos theta, the whole thing squared. And here's tan x plus y. And here's just one key thing to note. Cos inverse is not the same as 1 over cos. So let's say cos inverse x, it's not the same as 1 over cos x, because this right here is equal to arc cos, And we will use this to solve like equations, solving. And to represent this right here, you should do cos x, the whole thing, to the power of minus 1 to show that it's an inverse, the whole function inverse. And as we see here, cos theta as well as sine theta has to be in range of minus 1, smaller than or equal to cos theta, smaller than or equal to 1 to be solvable, because we'll look into their graphs later and to see that output can't be above 1 or below negative 1. Then we'll look into some sine rules and cosine rules, which we may already see in normal maths. So we have some sine rule, but first we have a triangle. So we have this triangle right here. The sides are small letters A, B, C, and the angles are big letters A, B, C. So we have first the sine rule. You can use sine rule and cosine rule depending on what angles you're given and what sides you're given. So sine rule for finding sides is A over sine A equals B over blah blah blah. And to find angles is basically the same, but they're all inverse, like they're all reciprocal. And for cosine rule right here, and this right here is for finding sides, and this right here is for finding angles. And here we have some graphs for trig functions. We have a sine graph, a cosine graph, and a tangent graph. So one key thing to note is that because sine graph and cosine graph looks really similar, you have to look at the difference. So sine graph crosses the origin, and cosine graph doesn't. Cosine graph crosses the y-axis at 0, 1. And this right here is basically 90 degrees. So you could say that cosine graph is basically 90 minus theta. So like cosine is equal to 90 minus theta equals sine, which is one of the identity that we saw just now from the first few slides. At tan theta, so we know that these dotted lines, they're all basically asymptotes that tan won't touch. So this will be undefined. Then we have how to solve trig functions, starting with some positive trig functions like sine x equals 1. And these look really complicated, but I just basically broke down the CAS diagram and put it into English words so it looks much more easier to understand. So let's just zoom in sine first to see how to solve for sine. So when you have an equation for sine, like sine theta 1 equals A, to solve for the first solution, it will be sine theta 1 equals sine inverse A. So as we see here, once you have an answer for sine, which is just theta 1, you do 180 degrees minus the first answer to get a second answer. So we have a solution right here, a solution. There will be two principal solutions. Number one will be theta 1, which is being given by doing sine inverse A. And the second solution is doing, let's just set it as theta 2. It'll be 180 degrees minus theta 1, like so. And you can of course add these 2 degrees by 360 degrees or minus by 360 degrees. Because remember from the CAS diagram, if I say here, this one right here, you can rotate 360 degrees to become a full circle around, which is just going back to the same point. Then we have number 2, cos theta 1 equals A. So the first answer will be theta 1 equals cos inverse A. So once you have the first answer for cos, you do 360 degrees minus the answer to get a second answer. So for solution, the first principal solution will be theta 1 using the cos inverse. And the second solution, theta 2, will be equal to 360 degrees minus theta 1, like so. And for tan x or tan theta, the first solution will be, like just now, tan inverse A. And then once you have the first answer, you do the answer plus 180 degrees to get a second answer. So solution, the first answer will be theta 1. And the second answer will be theta 2, which is equal to the first answer plus 180 degrees. Basically plus minus 180 degrees. Right, so And now we'll look at how to solve a negative trig functions where sine x or any trig function equals a negative number. So starting off with sine, so we can see that sine theta 1 is equal to minus a. So once you have what sine is equal to, which will be a negative number, you basically make the number positive and do sine inverse. So we theta 1 equals sine inverse. You ignore the negative number, the negative sign, so it'll just be sine inverse a to get a base answer. So in this case, all theta will be a base number. I like to call it base because it's much more simpler to understand, a base number, theta 1. So once you have the base answer, you do 180 plus the base answer and 360 degrees minus the base answer to get a first and a second answer respectively. So in simple terms, I'll just write it out. Solution. The first solution, which I'll set as theta 2, the first solution will be equal to 180 degrees plus the base answer, which is theta 1. And the second will be theta 3, which is the second solution, equals 360 degrees minus theta 1. And these are the solutions. And you can of course add 360 degrees or minus 360 degrees like a full circle. And for cosine, it's the same. Once you have what cosine equals to, which is a negative number, you make the number positive and cosine inverse it to get a base answer. So theta 1 equals cos inverse a, where this is a base 2. So once you have what the base answer is, you do 180 degrees plus the base answer and 180 degrees minus the base answer. So the first value, theta 2, 180 degrees plus the base answer, and the second solution, theta 3, 180 minus the base answer, like so. And you can of course add 360 degrees or minus it. And for the last one, tan, it's a bit different. So, but it starts off with the same. Once you have what tan is, you just do tan inverse the positive value, like so. And once you have the base answer, to get the first answer, you do 180 degrees minus the base answer to get the first answer. But for the second answer, you do 180 degrees plus the first answer. So let's just write here, solution. Solution. The first will be 180 degrees, theta 2 equals 180 degrees minus the base answer, and the second value, the second answer, theta 3 will be equal to 180 plus the answer. So let me just highlight this, solution, and of this, like so. And I'll just highlight the base answer too. So base answer, so. And we'll now look into some examples for trigonometric functions. So starting with number 1, if cos theta equals 4 over 5, find sine theta and tan theta. And we'll assume all functions are in quadrant 1, where they're all positive. So let's just draw a right angle triangle and set this as theta. So we know that cos is equal to SOH CAH TOA, so CAH A over H. And this corresponds to 4 over 5. So the adjacent is 4, and the 5 is hypotenuse, and this would be a Pythagorean, like a triple. So this would be a 3. So to find sine theta, so it's basically O over H, and tan is TOA O over A. And you can work this out using the different theta like O, H, and A to like configure it. So sine theta will be equal to O over H, like so. And tan theta is O over A, like so. Number 2, state the quotient of angle theta and find the value of the basic angle alpha if theta equals 250 and theta equals minus 60. So let's show a cast diagram for both, like so. So we have A. So theta is 250 degrees. So it'll be kind of like this. So it's in the third quadrant. Like so. So this will be 250 degrees. And remember that the basic angle can only extend from the x-axis. And this will be the basic angle because it's the smallest angle. So it's basically 250 degrees minus 180 degrees. So 250 minus 180 degrees. And this will be 70 degrees. And that's the alpha, which is 70 degrees. And number 2, minus 60 degrees, which will be around here. It'll be 60 degrees. It'll be in the fourth quadrant. And it's just 60 degrees as the basic angle. So 60 degrees right here. Like so. Then we have some more questions. We have 10 cos x minus 3 equals 0. And let's just solve it. And let's just set it in range of 0 to x to 360 degrees. Like so. So basically, number 1, you just rearrange a function to get equation to get cos x the subject. So it'll be cos x equals 3 over 10. And therefore x will be cos inverse 3 over 10, which you get the first answer by just putting it into the calculator. Cos inverse 3 over 10, which will be 72.5 degrees. And to get the second answer, we do 360 degrees minus the first answer, which is 207 degrees, 0.5. Like so. And then number 2, solve 3 sine x plus 2 equals tan 75. And let's just do it as 0x 360 degrees as well. So first we should just evaluate what tan 75 degrees is. So 3 sine x plus 2 equals tan 75 will be equal to 2 plus root 3. And now just rearrange the equation to get sine x the subject, which is sine x equals minus root 3 over 3. And to solve for x, you just do sine inverse root 3 over 3, which the first answer will be just putting that into the calculator. Sine inverse root 3 over 3, which is 35.3. And the second answer, you will get the second answer by doing 180 degrees minus the first answer, which gets you 144.7 degrees. And these are the two answers that are in range. Then we have solved this 2 sine x cos x equals sine x, giving the answer in 0 less than or equal to x less than or equal to 360 degrees. So the most intuitive thing that you would do is that you would just cross sine x out, right? But that's incorrect. You can't do that or else you miss some angles. So what you can do is that you can rearrange to get everything on one side. So 2 sine x cos x minus sine x equals 0. Group it together to get sine x and 2 cos x minus 1 equals 0. This means that sine x equals 0 and 2 cos x minus 1 equals 0. So you have to solve two functions. Just write this out. So sine x equals 0 and 2 cos x minus 1 equals 0, like so. So just solve these two functions. So the first one will be x equals sine inverse of 0. This will get us the first value of 0 degree. And you do 180 minus 0, which is 180 degrees. And remember, notice how the range is less than or equal to, so it can be 0 or it can be 360 degrees. And know how we can just add all the angles up by 360 degrees if it's in range. And in this case, 360 degrees plus 0 will be 360 degrees, which is in range. But you can't add it by 180 degrees or else it will be more than 360 degrees. So for the second function, it will be x equals cos inverse 1 over 2. And if you put into a calculator 1 over 2 you will get 60 degrees, like so. And then to get the second answer, you do 360 degrees minus 60 degrees, which is 300 degrees, like so. And for the last question, solve 3 cos x plus 2 sin x equals 0. So we can just first divide everything by cos x, which gets you 3 plus 2 tan x equals 0. Rearrange the equation to get tan x the subject, so it will be tan x equals minus 3 over 2, like so. So to get x, you just do tan inverse 3 over 2. And this will get you, let me just put in my calculator, 56.3. But this is not the answer, this is the base answer because we're dealing with a negative. Like so, right? So to get the first answer for tan, you do 180 minus the base angle. 180 minus 56.3 will be equal to 123.7. And to get the second angle, you do 180 plus the first answer, which is 180 degrees, plus 123.7, which gets us 303.7. And those two are in range, assuming 0 x 360 degrees as well. And these are the final answers. And that's it for this rules and examples video for IGCSE at Maths. Today we look into trigonometric functions. And I hope you found it useful and helpful. And if you did, please leave a like and subscribe, and ring the notification bell so that you never miss out on any future videos. And if you have any feedback or constructive comments about my channel, my YouTube or Instagram or my website, you can drop them off in the comment section and I'll reply to them, or you can email me. And you check out my social media in the description, for example LinkedIn or YouTube or Instagram. And if you need any learning resources or any teaching resources, you can check it out in my website in the description, or you can type it out in your browser at www.MakesItEasy.com. And I hope you all find it useful and helpful, and I'll see you all in the next video, which will be questions for trig functions or trigonometric functions. But until then, stay safe and happy learning.